She's Mary Miedema. I think I'm pronouncing correctly. With her talk, Meeting Contribution, where case study from Physiopy in making code contribution accessible. Mary is a doctoral student in biological engineering at McGill University, whose research focused on brain-body interactions and pre-processing methods for fMRI. She previously completed her Master of Science in Medical Physics at Dalhousie University, and she's an active member of the Physiopy open science community and a staunch advocate for inclusive research infrastructure. So, the stage is all yours.
Thank you very much for having me. I'll share my screen. So this is going to be a talk that I hope is useful in some way for everybody, but it's especially for people who are interested in getting small open science software projects off the ground. That's the perspective I'm going to be sharing today from Physiopy, as I talk about meeting contributors where they're at. So I want to begin just by taking a moment to situate the context of accessibility that I created this talk in. I want to begin by acknowledging that the research I do, in fMRI in general, and also all of the work I do collaborating with the global entity that is Physiopy, is physically located in Canada, in Tiohtià:ke or Montreal, and takes place on the unceded Indigenous lands of the Kanien'kehá:ka Nation. And another piece of context that I think is really, really important for me to acknowledge is that tomorrow is the 35th anniversary of an anti-feminist attack in Montreal, in which 14 women, mostly mechanical engineering students in their final years of study, were murdered at Polytechnic University, and many others were injured. So I wanted to pause and remember them in the opening to this talk. These are their photos. And below this, you can see a photo from a memorial in March last year for missing and murdered Indigenous women in Canada who are particularly vulnerable to violence in our communities. So I want to remember and acknowledge them as well. And there are some resources on the screen as well. I hesitated on opening a talk on collaborative coding this way, but reflecting on the values of MRITogether, especially those of openness and inclusivity, invited me to also reflect on who is here doing research with us and who is not here and why aren't they here. So I think it's really important to keep in mind that larger context of accessibility. Even as in the rest of this talk, I'll dive into a much more narrow lens on the accessibility of participation in collaborative coding projects. And one final remark I'll make here is that open science doesn't happen in a vacuum. So I've included on the left a link for the website for Open and Collaborative Science in Development Network. It's that link on the bottom, where scholars from across the Global South have acknowledged and explored in a very important way how we can contextualize open science to address broader systems of power and inequality. So I'll move from there into talking about ideas of open science, open scholarship, and collaborative coding spaces. Another thing I was reflecting on when I was writing this talk was a hackathon I participated in this January. It was really fun to hear our previous speaker also reflect on his experience with hackathons, and I really echo that they can be a really positive space to explore and develop expertise. This particular hackathon was Brain Hack Vanderbilt, and there Loon Belek gave a talk as the keynote speaker, and she did that both as a researcher engaging with autism and neuroscience and someone who has really, really worked hard to bring collaborative coding to neuroscience through the Brain Hack Project, which I will touch on again later in my talk. You can find her talk on YouTube if you search "To Build a Home, 12 Years of Brain Hack," and it talks about the history of that organization. So I'd strongly recommend checking that out. One thing in particular that she mentioned during her talk was some values that she identified as drivers of inclusion that are present in collaborative coding spaces in a way they aren't in the rest of academia. And how some of these principles that you will experience in a very firsthand way at a brain hack, things like team science, collaboration and not competition, horizontal governance systems, how centering those things can make a hackathon much more accessible to someone with neurodiverse traits than, say, a traditional scientific conference. And as someone whose introduction to open science was through a brain hack, kind of waded into one in 6 years ago now, as someone who didn't really know what open science was, but very quickly found things to be excited about, ways to develop my own expertise and to connect with others. I really want to echo that collaborative coding spaces can be uniquely accessible and inclusive as we do science. And so I want to suggest that when we do open science together, we're also moving into the bigger picture of open scholarship. I can define open scholarship a few ways: by looking beyond the boundaries of what we might traditionally call science and start thinking about other knowledge systems, whether that's a hacking collective or indigenous ways of knowing. Open scholarship also is something that includes, beyond research directly, the processes of mentoring, teaching, and producing educational materials. And crucially, it makes very explicit the importance of accessibility and inclusion. So what I want to think about for the rest of this talk, as I circle back to my own experience with Physiopy, is what brings contributors to an open coding project and what keeps them there. So for the rest of my time, I'm going to be talking about some case studies and lessons learned from Physiopy. I'll start with a quick introduction to Physiopy, and then I have 3 different case studies to talk to you about. The first involves organizing time to collaborate through brain hacks and code sprints. These are really both a kind of hackathon. And then I'm going to talk about kind of orientational materials for people who are participating in an open code project, namely the contributor guide. And lastly, I'll touch on Physiopy's experience with a more dedicated kind of mentorship and walking a contributor through our project with the Google Summer of Code. So I'll start by telling you a little bit more about Physiopy. We've been around since 2019. I've been a member of Physiopy since 2021. And we're a collaborative and open community that is really focused on how physiological data can be relevant to, included in brain imaging studies. And we do that 2 main ways. The first is developing open source toolboxes for handling physiological data. And the second is compiling open community practices. So our motivation for doing this is that making measurements about someone's physiology can tell you a lot about the kind of imaging data that you're collecting from them. Whether you're interested in doing QC on your MRI data, whether you're interested in investigating physiological correlates of MRI data, or for denoising MRI data. There are a lot of different possibilities. So one of the ways we do this is we're trying to give people both tools and practices that they can use to handle their physiological data, handle and acquire. And we do that through literature and open roundtables. So a brief overview of Physiopy's code base. We have 3 main toolboxes that we use for handling physiological data. The first is Phys2Bids, and you've probably heard about bids at other sessions, but briefly, this allows people to take proprietary physiological data and transform them into standardized, accessible data formats. And it also allows you to then plug in that standardized data into other tools, including our own toolboxes, Prep for Phys, which lets you pre-process that data, do some artifact handling, peak detection, and then again, pass that data along to our toolbox Phys2Denoise, which lets you compute metrics of interest for fMRI denoising. We have some supporting toolboxes, including PhysioQC, which is under active development. So how do you know if you've collected good physiological data or not? that's something we're working on developing. So if you're interested, you're more than welcome to join us. We're also working on curating a testing data suite for use, not just with our toolboxes, but with other toolboxes that are out there working with physiological data. And the last thing is that all of this code base is informed by our documentation for how to work with physiological data, how to acquire it, how to analyze it. And those community practices are compiled on a separate website. I'm just showing a little preview of it right now. It's again something that we're actively working on, and we released the first public version this year. One cool thing, and part of why I'm sharing it here, is that because this is a versioned set of community practices, we actually work on it through Git. So it's a website that is actually created through coding collaboratively, in the sense of working on markdown files and commenting on PRs. So it's a very accessible way, actually, of getting to know how GitHub can work, in that you don't really have to code. You can just experiment with version control and get some expertise on physiological data. So you can see the website there if you're interested. And once again, I invite you to take a look and get in touch if you're interested in participating. So how does all of this happen? The first thing is that we have open monthly meetings every third Thursday of the month. So 2 weeks from now, we'll be having our pre-holiday meeting, and you're very welcome to join us. You can just email physiopy.community@gmail.com if you'd like to. Aside from that, we have project-specific meetings on an as-needed basis. We have channels of asynchronous communication on Slack and development-specific communication on GitHub. But one thing I want to really highlight is that for us, as a fairly small open science software project, our most intensive development periods occur during brain hacks and code sprints. So I'll start by talking about what a brain hack is. It is a combination of a few different kinds of event, a hackathon, an unconference, a workshop. Essentially, it's a collaborative coding event. And they happen throughout the year. So I believe MRITogether right now is happening kind of during the same time as Brain Hack Global, which happens in December each year. And that may involve different satellite events in regions near you. You can go to their website, brainhack.org, and look for coding events near you. A lot of them do happen virtually, so there is something that is accessible to you if you're interested. And the OHBM Brain Hack, the OHBM Hackathon, which was mentioned earlier, is also a brain hack event. There are a lot of different modes of engagement for a small open science project. You could host your own Brain Hack Global event, for example. You could simply attend someone else's Brain Hack, and you can also check out the resources that Brain Hack Global has amassed. They include things like technical tutorials, but also good resources for how to host a hackathon. And my key recommendation for participating in this would be, if you go, propose really well-defined projects that are accessible to new contributors. But we've had great success with this, with Physiopy attending the OHBM brain hacks, typically introducing new people to our project, and getting all hands on deck to work on that project for a few days. And then some of those people do go on to become regular contributors to the community. So that's been a really positive experience for us. The key difference between participating in a brain hack and running a code sprint is that a brain hack tends to be a larger event. People are working on different projects, whereas a code sprint, much again like our previous presenter mentioned, might be more a specific kind of hackathon, similar to a lab group running a hackathon. A code sprint could just be your community running a hackathon. So I wanted to give a brief tutorial for what that could look like. I'm just going to mention some of the key components you could choose to include if you were running an online code sprint. As we've done, we typically run a code sprint in the last few days of the fall and winter semesters. since for our community, it works quite well to just have roughly 2 or 3 days of dedicated coding time that we're able to really focus on pushing Physiopy forward. So if you're running a code sprint online, I would say the barriers for doing this are quite low. All you really need is a welcome, essentially defining the projects that your community is going to be working on during that code sprint, briefly penciling out what time is going to be hacking. Are you going to be doing that asynchronously? How will you check in with each other? If you are more interested in drawing in new contributors, or kind of re-arousing the interest of dormant contributors, it can be really nice to include a seminar in your code sprint, something like bringing in a guest speaker, or if that's too difficult, even just hosting a journal club with something that is relevant to your project. Can be a really good way to have people come in, even if they're not feeling up to coding, but once they're in, they're in. Beyond that, the unconference format is something that has worked really well to informally host during a code sprint. Essentially here you're just blocking out time for people in your community to come and share about their research if they want to, kind of an impromptu presentation space. You can include social events in your code sprints. You can also include tutorials if there are people in your community who have expertise in a certain aspect of coding and want to share it with others. This is a really great opportunity to do that. I recommend recording it so it's available for people later on. And then typically budgeting some time at the end of your event to wrap up projects and make sure that you're able to transition out of the code sprint with things in a place you can pick them up again later. So alongside all of this, logistically, you'll need, beyond the schedule itself, a registration. I would recommend an online form for registration. This is a good way to get some accountability for people who are planning to participate and make sure that you're able to keep in touch with them, give them all the information they're going to need for when things are happening, where things are happening. Speaking of which, you will need a meeting platform, whether that's Zoom or something else. Other times for our code sprints, we have used platforms like Gather or Work Adventure. This is really a matter of personal preference. Another thing that you should have, apart from a meeting platform, is a messaging platform to work from, whether that's something that your project already has established, like a Slack space. You can also use Discord or Mattermost. These are all really good forums for asynchronous communication. At this point, you may start to see why I recommend having a code sprint website. It's quite simple to set one up on GitHub. But it's a really nice idea to have all of that information in one place with your registration link, and then to be able to share it not just with contributors within your community, but if you're feeling ambitious, inviting new contributors as well. Another thing to consider ahead of time for your code sprint is project infrastructure. So whether that looks like setting up some containers to run and test code, or setting up a project board for progress tracking on GitHub, it's good to think about that in advance. And the very last key component of any code sprint is how you're going to collect feedback from people, because it won't be perfect and people will have ideas for how to improve it for the next time. So I really recommend sending around a feedback form to everybody and just seeing what you could do to adapt to your community's needs. And if you're curious about what this can look like, you can go on Physiopy's GitHub and check out some of the repositories that correspond to websites that were created for some of our brain hacks and code sprints. You'll see they're actually quite similar in format, brain hacks and code sprints. It's really just a difference in scope. So again, I'm going to recommend going to the brainhack.org website because they also have some great guides for setting up these kind of events. I will say they're a little bit more tailored to running these events in person. So just to share some lessons from the last coding events Physiopy has run, commitment is really key. I think getting the buy-in from people in your community about what format will be helpful for them You can discuss whether you want to go to the trouble of organizing a seminar, whether a 1-day, 2-day, 3-day event is manageable in scope, finding times when people's schedules are going to align. Really take the time to see what people are willing to contribute to your project as far as their time goes, and plan from there. Beyond that, I would say it's really worth doing, organizing a coding event, because it's a great way to revitalize stalled project. Whether that's just taking a moment to take inventory of what your community is working on and where new people need to be assigned, or that it's hard to get community consensus on the direction of a project, and it would be great to have everybody in one place to hash that out. A coding event can be a really much needed burst of momentum for something that's stalled. I would also give a tip that a little bit of prioritization can go a really long way. So especially at the start of a code sprint, if you are letting everybody rapid fire ideas for what they want to work on during project pitches, that's great. But don't let a coding event balloon your scope. I think choose things to focus on and make progress on and go from there. And that said, don't let the event be the end. Collect all of the great ideas that come out of it. Figure out at the end of the event who's going to keep working on what, or when the next round of work will happen on something, and go from there. So I want to briefly now switch into some of the barriers to code contribution that we can encounter when working with open source software, because a coding event is all well and good, but how do you take someone at a coding event who hasn't contributed to your project before and sit them down and get them coding? So here I'm showing some of the results from a meta-analysis of papers that examined different barriers to open source software contribution, and they gathered them in some different categories, like finding a way to start. Difficulty finding an appropriate task to start with was a really big challenge for some of these softwares. Technical hurdles like code complexity also can play a role. Documentation can be a barrier in numerous ways, whether there's too much documentation, it's outdated, there's not enough documentation, or the documentation and code comments are unclear. Those can all be different barriers. Social interaction was surprisingly the most reported barrier. The lack of social interaction with project members specifically, or not receiving timely answers to questions. Another significant barrier was just how much experience and knowledge a newcomer to the project has. Lack of technical experience is a big one, which makes a lot of sense, but lack of domain-specific expertise or knowledge of the project itself can also play a role. So one of the biggest places to address these barriers is a contributor guide. And a contributor guide, in a nutshell, is something to set up to show people how to contribute to your open source project. Usually it's a set of documentation either in the repository of your GitHub project or on a website. Typical components would include a quick start guide for people who kind of have done open science software before and know where they're going. Very specific contribution opportunities. If you have one package that you're actively looking for people to contribute to, that's a good place to specify it. If another package is really just in maintenance mode, again, these are good things to specify on your contributor guide. One of the largest parts of any contributor guide will be an overview of its workflow. If it's on GitHub, it'll include things like how do you submit an issue? How do you comment? How do you commit? How do you do a pull request? So all of that will be on there. Instructions for testing code, channels of communication, and how contributions will be recognized. Some key principles here are that a good contributor guide will be visible, up to date, and relevant. And if you want to see an example of a really good contributor guide, I recommend checking out the NIPREPS communities. I think they do a really, really good job at balancing all of those different requirements. So one of the more fun code sprints we've had was last year. this year. And we actually had a code sprint that was just dedicated to getting feedback from our contributors on our own contributor guide. And I've put a QR code here that was a survey developed by some of our community members to get a better sense of what barriers existed towards contributing to our code base. So if you're interested, you can have a look at it, adapt it to your own uses. Some of the main feedback we got during that code sprint was that people didn't know our contributor guide existed. I was one of those people for a good year or two, actually, when I started contributing to Physiopy. So we've fixed that. We've made it much more visible on our website, and we now explicitly discuss it more intentionally with newcomers. Another piece of feedback we got was that the contributor guide was too long and kind of overwhelming. And this is something that can happen really easily when you write a guide to everything you need to know to contribute to an open source project. So how we've tried to address that is we converted things from a longer document into a wiki-style document, so you can navigate much more easily to the specific part with the information you need. As well, it needed an accuracy check, so we removed some outdated info. Some feedback that I and others are still working on incorporating is to add more checklists and flow charts. Again, looking at a wall of text is off-putting. And making really clear to have front and center in the contributor's guide how and who to ask for help when you're stuck. Because I think for most of us, not just newcomers to an open source project, at some point you will be stuck. So I'll show just briefly a few snapshots of what the contributor guide looks like, just to give you an idea. You can see on the left the ways we've structured some of our information. We have a getting started guide specifically for the kind of person who joins your team during a hackathon but doesn't know the project very well yet. We have more specific information for someone, say, reviewing a PR or working on testing and code coverage. So you can see this ranges from more talking you through what open source software development can look like to the nitty-gritty of how to use labels on GitHub. And I will say parts of it are still under development. We're still very actively working on them. One vision we have for our contributor guide as a community is that we'd like to have a section that is quite technical for people who are looking to jump into some of the tools we're using in our software packages. Things like pre-commit, CircleCI, PyTest, PyPy. We're not looking to reinvent the wheel here. We won't be developing a full educational course on how to interact with these tools, but just linking to things that we've found ourselves helpful for learning them in the past. So that's where our contributor guide is headed. We're really happy for any feedback you have or for you to use it as inspiration for what you're doing. I'll pause and talk about mentoring because the idea that anyone can read a guide and know what they're doing enough to function independently would again be misleading. So there are different ways that in a small open source scientific project, mentoring may exist. The most obvious one is onboarding new contributors, welcoming someone, telling them where information is, how things work. That is a kind of mentoring. We might also have mentoring that comes in the form of leading specific projects within your community. Code review is really another space where something similar to mentoring is happening. You know, you're giving each other feedback on what you're doing, especially when a senior developer is giving someone new a code review. And lastly, you might have dedicated forms of sharing expertise, whether that's recording a tutorial or leading someone through a code crawl. And so these are things we're exploring within our community, what forms those take, how regularly we offer mentoring to new people, because it is a demand on the resources of the community. And one thing we found this last year that we were quite excited about was the opportunity to participate in Google Summer of Code. And this is a really well-known entity in open source software. They celebrated their 20th anniversary this year. But it's a global online program focused on bringing new contributors into open source software development. So typically over the summer, contributors will work with an established open source organization on a program project under the guidance of mentors. And what's really exciting is that this last year, they made not just students eligible to be contributors or mentees during this program, but actually anyone new to open source. So anyone new to open source could apply to Google Summer of Code. So what does it look for in a mentoring organization? You need to have good documentation. Ideally, you will have some ideas for newcomer-friendly tasks with a defined scope and a really collaborative environment. It offers an exchange compensation for contributors. So this is huge to bringing someone onto your project, being able to compensate them for the time they're going to spend contributing to your code base. There's huge outreach potential for mentors as well. You get access to that whole pool of applicants. And then there's also a really great community of support for mentoring. So as I said, I feel very lucky to have been able to participate this summer as a mentor. And I want to thank the International Neuroinformatics Coordinating Facility, INCF, who actually took on the role of a mentoring organization for a number of smaller open source projects in neuro-adjacent spaces this summer. So if your open science project is connected to the brain, I would really recommend considering doing Google Summer of Code through INCF. To give you a very quick idea of our project this summer, we had one contributor, Yorgos, who came in, and we were able to tackle a much more ambitious project over this span of time than we were during our coding events. So thanks to his effort, we were able to create a new software package, Physutils, which bridges some of the gaps between our previous packages, and in particular, really improves our ability to work with data standardization across these different packages. So that's been very exciting. Some of the tips I, again, would have if you plan to participate in Google Summer of Code. It's a great opportunity to take on these bigger projects, but again, depending on how much capacity you have on your team, you could consider assigning several mentors to one mentee. And this is what we did in Physiopy. Worked quite well for us over the summer. Really don't underestimate your project's appeal to potential contributors. It may seem very niche to you within your particular domain, but the people who were applying to Google Summer of Code seemed very, very interested in interacting, even if they were from very different backgrounds than we expected. And lastly, Google Summer of Code has a lot of great guides for mentoring people when they're engaging in open source science for the first time. So even if you don't participate in the program, you can take advantage of that. So I'm just about through my presentation, but I just wanted to provide some questions to reflect on as we wrap up. You can think about specifically what accessibility looks like for your projects. What are some of the barriers that contributors to your projects face? And on the other hand, what are some of their reasons for contributing to your project? Are you providing them value as they contribute to your project? I particularly bring this up as I was preparing for this talk. I found a statistic that was a little bit worrisome, but that over the 4-year period from 2018 to 2021, 44% of volunteers worldwide stopped volunteering. And of course, those were the COVID years. But I think it's worth thinking about the fact that open science is in a lot of ways booming, but open science software is very, very demanding. And as people spend more time potentially thinking about how to integrate open science into their own research, it's worth considering how much bandwidth people have to volunteer for something like open science software, which is traditionally not as recognized as other academic contributions. So I say this because the closing session of MRITogether will be happening in about 10 hours. And we can chat more at that session too. I'll be moderating that one. It's on sustainable volunteering. So I hope to see you all there. And I'd like to conclude by thanking you for your attention, thanking MRITogether for having me. I'd like to thank my research group, supervised by Professor Mitzes at McGill, and of course the Physiopy community.